Okay. So today we're going to be doing lesson 1.1. In your packet, you'll see that if you open to the second page, you'll see your vocab area, right? So each of our units, we're going to start out with vocab. We might have to flip back to it at some points, but right here is where you're going to fill in where the notes start, okay? And then once we're done with the vocab, we'll go into the 1.1 lesson. So our first vocab that we're going to look at is equation. Equation is a mathematical sentence that contains an equals sign between two expressions, okay? Remember yesterday we did our warm-up and we had our expressions that didn't have an equal sign? An equation is just two expressions that are combined together with the equals. So an example of an equation would look like this. X plus 4 over 1 is equal to 11. You have an expression on the left-hand side and on the right-hand side, and there's an equal sign that combines them together. Okay? So that's an equation. Our second vocab word is solution, and that will be found on the second page of your vocab sheet. Now a solution is any value or values that makes an equation true. So what do we mean by that? Well, a solution of the equation that we just had would be 6 3/4. Because when we plug 6 3/4 in for x and we solve for it, we find that the left-hand side of the equation equals the right-hand side of the equation, making the equation true. Okay? Once you have that complete, yep, Caesar, did you have a question? Yep, so you're just going to want to write your example. It doesn't have to be exactly the same. It can be that one. Once you're done with your vocab, you're going to want to go to lesson 1.1. In your booklet, you'll see that there is a 2 in the lower left-hand corner. That's how you know you're on the right page. I'm going to give you about 10 more seconds to fill in your vocab, and then we'll head on over. Yep. Yeah, we can go over it later. Okay, about 5 more seconds. We're going to head on over. You guys, if you give me your time, we'll get through this quickly, and then the rest of your time is yours to work on your assignment, okay? Okay, so example 1. This is in your book packet as example 1. A and B are both in there. So example 1 is saying y equals, or 3y minus 1 equals 32. And it's asking us, is 10 the solution? So for this, what we're going to do is we're just going to plug in for our y what it's asking us. So it's asking us, is 10 the solution? We're going to plug that in for our variable. When we do that, we get 3 times 10. And then we write the rest of the expression, which is minus 1 equals 32. Remember, this is in your book packet, so you just need to be following along. The extra examples are the ones that we're going to be writing in our notes. So when we substitute 10 for our y, we do 3 times 10, which is 30. We write the rest of the expression, which is minus 1 equals 32. 30 minus 1, we get 29. Now 29 does not equal 32. So is 10 a solution? No, because it's not true. Example 1b. It's asking us, determine that if the number given is the solution. So we have x over 2 plus 6 equals 2. Is 8 the solution? What are we going to be plugging in for x? Negative 8, because it said, is this 8 negative 8 the solution? So our first step, we're going to write out the equation. We're going to substitute negative 8 for x. When we do that, we have negative 8 over 2 plus 6 equals 2. We divide. When we divide negative 8 by 2, we get negative 4. Plus our 6. When we simplify that, we get 2 equals 2. That equation is true. So 8 is the solution. Okay. extra example number 1. These are not in your notes, so this is what you're going to be writing down on your notebook paper or a line sheet of paper. And I would label this 1.1 lesson so you know that these notes are for 1.1. So we're going to do A together, and then you're going to have time to do B. If you're listening to the recording, all you need to do is just pause the video and then continue it once you're done. So for A, we have 4p plus 3 equals 17. Is 5 the solution? So what's our variable in this equation? P is our variable, and it's asking us, is 5 the solution? So that means we're going to have to plug 5 in for P, right? Okay. So is it on the ground right there? Okay. So we have 4p plus 3 equals 17. We said that we're plugging in 5 for P. So we have 4 times 5. We're going to write the rest of our equation, which is plus 3 equals 17. When we do that, we have 4 times 5, which is 20, plus 3 equals 17. When we do 20 plus 3, what do we get? 23. Now, does 23 equal 17? Does not. So that means 5 is not a solution. Okay? Now I want you to do B on your own. I'm going to give you about 40 seconds to do that. We have x over 6 plus 7 equals 11. Is 24 the solution? So take the time to do that right now. Again, if you're watching the video, pause the video now. Okay, about 10 more seconds. Okay, so now our first step is going to be, shh, you guys, when I'm talking, I should not hear talking, okay? The faster I get through this, the faster you guys have time to work on your homework. So our first step, we're going to write out the equation. We have x over 6 plus 7 equals 11. What are we going to plug in for our variable x? 24, because it's asking us, is that the solution? So we know that this is going to be our x. So when we do that, we have 24 over 6 plus 7 equals 11. Now we need to simplify the left-hand side of the equation. So what's 24 divided by 6? 4. And then we have our plus 7 is equal to 11. What's 4 plus 7? So 11 equals 11. Is that true? So that means 24 is a solution. So we would say yes. Does anyone have any questions on that? Caesar, what's your question? Yes. You guys, when I'm talking, please just listen. So we found that A was no and B was yes. Okay, this is vocab again. So we're going to go to our vocab sheet. Our vocab. Yep. Yeah. Okay, so our next vocab word. This is the last one on the vocab sheet that we're going to do today. You'll fill out the rest of your vocab as we go through the rest of the lessons. So the inverse operation, that means operations that undo each other, okay? So in your notes, an example of this would be the properties of equality. So this is already in your notes. You don't have to write it down or anything. So when we draw, what we'll draw in for our vocab is an inverse operation. How do we undo multiplication? We do division. How would we undo subtraction? We do addition. So you'd write that in for your visual. Can be anything that will help you remember what inverse operations mean. Yes. Caesar, we can talk later, okay? Let's just get through this lesson. We're going to continue on. Shh. Okay, you guys. I'm recording this too, okay? So can we please have the talking to a minimum? So, the properties of equality. If I have an equation sign, Caesar. If I have an equal sign, it means that two sides of the equation are equal, right? If I have A equals B, that means I know that the two sides are equal. If I add C to both sides, do they stay equal? If I add the same amount to both sides, do they stay equal? They do. If I subtract the same amount from both sides, do they stay equal? If I multiply the same amount by both sides, does it stay equal? No. What if I divide the same amount by both sides? Does it stay equal? It does. So those are the properties of equality. Those are in your notes, so you don't have to memorize it. What? Okay, so now we're going to head on over to example 2. You should be back in your notes. It'll be page 3. So example 2. Shh, this isn't an opportunity to talk, okay? Let's follow along. Example 2 has A, B, C, and D that we're going to go through. You don't have to write these down. They're in your packet, okay? So A, we have x minus 6 equals 22. So what we need to do is this is a one-step equation. Our x is being subtracted by something. What do we do to undo subtraction? Addition. So we're going to add 6 to both sides. When we add 6 to both sides, we're left with just x on the left-hand side. 22 plus 6 we get is 28, so our x is equal to 28. It also asks us to check each solution. So what does that mean? It means plugging in what we got for x into our original equation. When we do that, we plug in the 28 for x, subtract it from 6, we get 22. 22 equals 22, so that's how we know that our solution is correct. Okay? B, 7x equals 77. Our variable is being multiplied by something. How do we undo multiplication? Division. We do the inverse of multiplication, which is division. We divide each side by 7 because we want x by itself. When we divide 7x by 7, we're left with just x. When we divide 77 by 7, we get that our x is equal to 11. Okay? Now it's still telling us to check each solution. So what do? We plug in our x to our original equation. So 7 times 11 is 77. Both sides are equal to each other, so we know that it is true. Okay. Example 2c. So we have x plus 10 equals negative 7. We want our x by itself. So what do we have to do to get x by itself? Do you know? Subtract 10 from both sides. So when we do that, we get an x by itself, and then we have negative 7 minus 10. What's negative 7 minus 10, Jaden? Negative 17. So we have our x is equal to negative 17. Now it also is telling us to check, okay? So we're going to plug in our negative 17 in for x. When we do that, negative 17 plus 10, we find that's negative 7. It checks out, so we know that our solution is right. Okay? Last one, and then we're going to do one together, and then you guys are going to have some to practice. We have x divided by 5 equals 21. So our x is being divided by something. What's the inverse of division? Multiplication. So we multiply each side by 5. When we do that, we're left with x by itself on the left-hand side. 21 times 5 is 105. And then we found our x, but it's asking us to check each solution. So we have to plug 105 in for x. 105 divided by 5. When we do that, get 21 equals 21, so we know our answer is right. Okay? Okay, extra example. We're going to do A together. So, first step, I'm going to write out the equation. X over 12 equals 5. Okay? So our x is, what's happening with our x? It's being divided by 12. So what's the inverse of division? What do we say? Multiplication. So we're multiplying each side by 12. When we do that on the left-hand side, what are we left with? Just x, because our 12 cancels out. And then we're left with 5 times 12. What's 5 times 12? 60. So our x is equal to 60. Are we done? No, because it told us to check our solution. So what do? We plug it in for our x. 60 over 12 is equal to 5. Well, 60 divided by 12 is 5, so it checks out, right? Okay. Now, you guys are going to try extra example 2B. Remember, these are what you should be writing in your notes because they are not in your notebook. Take about, nope, we're doing this independently. Take about 30 seconds to do B. Should not take you long. Nope. Okay, 10 more seconds. Okay, so our first step. You guys, when I'm talking, I shouldn't hear any talking. Okay. So we're going to write out our equation. We have negative 3x equals negative 21. What is our x being multiplied by? Negative 3. So how do we divide it by negative 3 to get x by itself, right? So when we do that, we have our x is equal to negative 21 divided by negative 3. What do we get when we divide negative 21 by negative 23? We get 7, a positive 7, because we are taking a negative and we're dividing it by a negative. Now, are we done? No, because it told us to check the solution. So what we do, we plug in our 7 for x. When we do that, we have negative 3x, which is negative 3 times 7. We get negative 21 because a negative times a positive is a negative, right? And 3 times 7 is 21. So we know that our solution is correct. So now we know we're good to go. So we found that A was x equals 60 and B was x equals 7. So now example 3. This is in your packet. It's going to be on the next page, page 4. So example 3, this is now a 2-step equation problem, okay? So that means we're going to have to do 2 steps to solve for our x. So for A, we want to get the 8x by itself first, but it's being subtracted by 3, right? So Gio, what's our first step? Okay, yep. You have to do the plus 3 first. So we want to get 8x by itself on this side, okay? So it's being subtracted by 3. Before we can do any division or anything like that, we have to get rid of that negative 3. So we would add 3 to both sides. So when we do that, are we ready now? Are we okay? Okay. So when we add 3 to both sides, what happens? Well, the 3 cancels out on this side. We're left with just 8x, and then 85 plus 3 is 88. So what do? We have to divide to get x by itself. So when we divide each side by 8, we get x by itself on the left-hand side. 88 divided by 8 is 11, so our x is equal to 11. Now it's asking us to check. So all we got to do, plug our 11 in for x. Well, 8 times 11 is 88, minus 3, we get our 85, and we know that it checks out. Okay? Example 3b, this is still in your packet. We have negative 2 equals x over 9 plus 5. Now, what would our first step be in this equation? Tyler? Subtract 5 because we want our x over 9 by itself, right? So when we do that, we subtract it. We get x over 9 on the right. Negative 2 minus 5, we get a negative 7. Then we still have our negative 7 equals x over 9. Now it's a one-step equation. So how would we undo the division in a one-step equation? Times it by 9 because we want our x by itself. So we multiply 9 by both sides to keep it equal. When we do that, we're left with just x. And then 9 times a negative 7 we get is negative 63. Okay? Again, it's telling us to check. We plug in our negative 63 in for where we see x. When we do that, we simplify and we find that it is equal to each other. So we know that our solution is true. Extra examples. These are not in your workbook, so you have to write these down on your notes. So it's asking us to solve for x and to check each solution. So we're going to do A together. So A, I'm going to write it out. It's negative 34 equals 6 minus 4x. So what we have to do is we have to get our term with our variable by itself first in a two-step equation. So we have an integer 6 that is on the right-hand side of the expression. How do we get rid of that 6? Yeah, we'd subtract it from both sides. So when we do that, we have negative 34 minus 6. What is negative 34 minus 6? Negative 40. And then what are we left with on the right-hand side of our equation? Negative 4x. Remember, we didn't get rid of this negative sign, so it's negative 4x. So now it's a one-step equation, right? Our variable is being multiplied by something. So how would we undo the multiplication? Caesar? Divide it by, what do we do? Positive 4? Negative 4, because it's a negative 4 up here. So we get x by itself on the right-hand side. Negative 40 divided by negative 4. We get a positive 10, because a negative divided by negative is a positive. Then we need to check our solution. All we do is we plug it in here. We have negative 34 equals 6 minus 4 times 10. Well, 4 times 10, that's 40. Remember, we're still subtracting. We get negative 34. 6 minus 40 is what? Negative 34. So does our equation check out? It does, so that means our solution's right. Okay, now I'm going to give you about a minute to do B and C. So B is x over 5 plus 11 equals 17. And C is 5x plus 1 equals negative 4. So do B, and then once you're done with B, you can head on to C. About 1 minute to do that, okay? Again, if you're watching the video, you can just pause at this moment and then press play once you're done. Work with your partner if you need help, okay? About 30 more seconds, and then we'll go over. Okay, 10 more seconds. Okay, raise your hand if you can tell me what the first step to B would be. Jacob. We would subtract 11. So we have our x over 5 plus 11. You guys, if I'm talking, I should not hear any talking. We're subtracting 11 from both sides, like Jacob said, because we need to get our x by itself, right? So we have our x over 5 is equal to, what did you get when you got 17 minus 11? You got 6. Caesar, what'd you do next? You multiplied by 5. Why did you do that? It's the inverse of the division, right? So we multiply 5 by each side. When you did that, what did you get 6 times 5 is equal to? 30. So our x is equal to 30. Are we done? We have to plug it into our equation to check it, right? So when we do that, we just do 30 over 5 plus 11 equals 17. What's 30 divided by 5? 6. So we have 6 plus 11 equals 17. What's 6 plus 11? 17. So this checks out. So we know our solution's right. Okay, raise your hand if you can tell me the first step to C now. Tyler? Subtracting 1. Why are we subtracting 1? To get 5x by itself. When you did that, what did you get? Negative 4 minus 1 is equal to, Tyler? Negative 5. Okay, with a raising hand, who could tell me the next step? Jaden?
5.
We divide 5 on each side. Why would we divide by 5? To get the x by itself. When you did that, what did you get your x is equal to? Negative 1, because we're taking a negative 5 divided by a positive 5 to get a negative 1. So, what's our next step? We found what x is equal to, but are we done? No, it asks us to check each solution. So what we do, we just plug it in. We found our x is negative 1. We plug that in for x plus 1 equals negative 4. What's 5 times negative 1? Negative 5 plus a positive 1. What do we get when we simplify negative 5 plus 1? Negative 4. So it checks out. So we know that our solution is correct. Okay. So now, when we have equations that we need to create out of word problems, we'll use these words right here. So at the bottom of your page, you'll see on example 3, you'll see that there's all of these keywords, okay? So when we see words like plus, sum, increase by, more than in a word problem, we know that we're talking about addition. When we see minus, difference, decrease by, less than, we know that that means subtraction, right? So multiplication would be times, product of, double, triple. These are all keywords that you want to look out for. Division is divided by, quotient goes into or per, and equals is equal to, is, or you could even have equivalent. Okay? Okay. We're almost done. So example 4, this is in your packet. It's not going to be on the next page. It's a word problem. It's saying 8 more than 3 times the number is 29. Write and solve an equation to find the value of the number. Well, we just talked about some of these keywords. What would more than mean? More than would be adding, right? So it'd be adding. What is 3 times? What would that mean? Multiplication. What about a number? We didn't really talk about this. A number would be our variable, which we could call x, because it's some unknown. We could say this is our x. What about is? Do you remember what is? Equals. Yep. Okay. So we kind of already dissected the problem, right? So our first step is going to be, when we're writing the equation, is we're going to look at where the variable is, okay? So we're going to look at it's talking about the variable. So it said 3 times a number. Well, we said a number is equal to x. So what would we write as an expression for 3 times a number? X would be our number. What about 3 times it? We would multiply by 3, right? So our answer would be for that one, 3x. Okay? Now, it's saying that there's 8 more than. So we need to take our 3x. We need to add how many? 8. So we have our 3x plus 8. Are we done? No, because we still have what? It equals 9 and 20 is 29. So when we do that, we take our expression that we had equals to 29. Now we've written our equation, but we need to solve for it. So we just do what we've normally been doing with a 2-step equation. We subtract 8 from both sides because we want our variable by itself. When we subtract 8 by both sides, we get 3x on the left. 29 minus 8 is 21. Then it's just a 1-step equation, right? Our x is being multiplied by something, so how do we undo the multiplication? Division. We divide by 3 on both sides. Our x is equal to 7. Okay? And the way that we would check this is we just plug in 7 for x. Okay? Okay, extra example. This is not in your book, so this is what you should be writing down in your note paper or in your notebook. So, extra example 4, 10 less than 6 times the number is 8. Write and solve an equation. I'm going to give you about a minute to write out your equation and solve it, and then we'll go over it together. We're almost done, and then I'll pull up the assignment that you guys have. Yeah, so write out your equation and then solve it. The variable? Yeah, you can do that too. Okay, I'm going to give you about 30 more seconds, and then we'll go over it together. In like 2 minutes, we're almost done. Okay, 10 more seconds. Okay, we're going to go over it now. So I need everyone quiet. Okay, we're going over the question right now, okay? So, shh. So we have 10 less than 6 times the number is 8. You guys, when I'm talking, we're almost done. When I'm talking, you guys gotta stop talking, okay? So 10 less than 6 times the number is 8. Remember, we find our keywords. Less than is a keyword, times a number is a keyword, and is a keyword. So what does less than mean? Minus. What does times a number mean? You're multiplying by your x, right? And then what does is mean? Equals. So we're going to start with what we're multiplying our variable by, right? So the part that says a number. So what would we write for 6 times a number? 6x would be times a number. Now, our 6x is 10 less than. So how would we represent 10 less than? Minus 10. So we have our 6 times a number, 10 is less than that. It doesn't matter if it's negative 10 plus 6, but it does matter if you do 10 minus 6x, because then that's not the correct answer, okay? So we're starting with our variable, which is 6x. And then if you see 10 less than, you know that this is going to be a negative 10. So all you're doing is combining it. So you have your 6x minus 10. I'm still talking. And what is that equal to? What does it say in our word problem? 8. So now we have our equation. Didn't tell us just to get the equation, it told us to solve for it. So now it's a 2-step equation that we're just going to solve, which we've been doing for. So we want our variable by itself. It's being subtracted by 10. How do we undo the 10? We add 10 because the inverse of subtraction is addition. When we do that, we're left with just 6x on this side. What are we left with on our right side? 18, because 8 plus 10 is 18. Then we have our 6 that's being multiplied by x. How do we get x by itself on the left? We divide by 6 because it's the inverse of multiplication. We do that on both sides. So our x is equal to 18 divided by 6, which is 3. Okay? And we would solve for, or we would verify that this is correct by plugging it back into our original equation. 6 times 3 minus 10. Well, 6 times 3 is 18. Minus 10, we get 8. That's equal to 8. So we know that it's right. Okay? Any questions on the word problem? Okay, this is just the last little bit. So why is it important to show your work and check your solution when solving for equations? Gio? Yeah, just to make sure your answer is correct with checking it. And then you want to show all your work, because if your answer is not correct, and when we check it and it's not equal on both sides, if you show all your work, you can see where you went wrong, okay? So that is it for lesson 1.1. The rest of the hour is yours to work on the assignment. The assignment is up here. It is page 5 in your booklet, numbers 1 through 9 odd. Then you're going to be doing 10, 12, and then 15 through 29 odd, and then 30 through 32 all. Yeah, you can write on the packet or whatever you prefer. So I would suggest circling all of the ones that you need.